Hey folks, we got one another example of parallel circuits, and this one's going to be like a puzzle, kind of like a Sudoku puzzle. So the title is Parallel Circuit Puzzle. If you would, take a moment to copy the following two things down. Copy this new circuit down with different values, okay, and copy this chart right here. So I'll give you guys a minute. Go ahead and pause the video and copy both the circuit down and the chart. All right, so if you have all that copied down, what's going to happen is we're going to give you just a chart on your practice and on your test and so on. And your job is to fill in all the blanks. So you're going to use the rules that we've developed for parallel circuits to do that. Okay, so first off, what's the same everywhere in a parallel circuit? Well, the voltages are the same. So if this battery voltage is 24 volts, that means each voltage drop for each resistor also has to be 24 volts. So right away, we have these values in our chart filled in. And again, this is for parallel circuit. If this were a series circuit, these would not be all the same, but for parallel, they are. Okay. Now, the way this chart is written out, it's written as Ohm's law. V equals I times R. So if you know any two in the row, you know the third. So for instance, looking at R1 here, 24 equals 2 times what? Well, that has to be 12. So R2 has to be, R1 has to be 12 ohms, okay? For R2, 24 equals what times 8? Well, that's 3. So the current through R2 has to be 3 amps. Notice that I'm going to go ahead and draw it in here. Now, when you guys go to do these tables, you don't have to draw the circuit out, but I wanted to draw it out so you can kind of see what's happening. Finally, for R3, 24 equals 1 times what? Well, that's 24. So that resistance is 24 ohms. Okay. Oh, and we already know that current that was given. This current way over here is 1 amp. Okay. Now, looking at the top row, there's a couple ways you can get the values for the top row. Okay. One way is I can get the resistance first if I want by doing looking at these three resistors and doing the 1 over thing. So I can do 1 over Req equals 1 over 12 plus 1 over 8 plus 1 over 24. And so I could add all those up. Let's see if I can do that real quick. This would be 2 over 24 plus 3 over 24 plus 1 over 24. Ooh, that's a plus, which equals 6 over 24, which equals 1/4. And Req would just be that flipped over. So it'll be 4. So the total equivalent resistance of this parallel circuit is 4 ohms. Okay, but perhaps an even easier way to get the equivalent resistance, and this is the way I would actually do it, is what's my total current? Okay, well, if I look at this junction right here, 3 amps and 1 amp come out of it here and here. That means 4 amps has to feed it. The 4 in has to equal the 4 out, and this also has to be 4 amps as well. 3 plus 1 going in has to equal 3 plus 1, which is 4 coming out. And then I look at this junction and I say, oh, how many amps come out of it? Well, 2 plus 4 is 6. So that means that 6 amps have to be feeding this junction up here. So 6 equals 2 plus 4. So my total current is 6. And now to find my total resistance, I just use Ohm's law. 24 equals 6 times what? Well, that's 4. Okay. So when you get to puzzle type problems like this, you're going to use your Ohm's law, and you're going to use the properties of parallel circuits, and you're going to look at adding and subtracting currents in junctions. I hope that was helpful. Thank you very much.